Hi, this video is a recap of my RetroChallenge project for October 2021. The project was to get a good working demo of a Mumps interpreter for the TI-99 4A. And I've done that, and I want to run through some of its capabilities in this video. So here we are at a login screen for the TI-99, and I'll go ahead and uh, hit a character return there, and we can see option 2 shows the virtual cartridge for the Mumps interpreter. So we'll go ahead and get it started, and takes you into Mumps. And for any programming language, right, the first thing you got to be able to prove is that you can do a hello world program. So W command is write in Mumps. We will write hello world, and certainly pass the first test here. But seriously, I'm going to go ahead and load a short Mumps program that will run through exactly what is Mumps and what's required to run this version of Mumps on the TI-99 4A. So we're going to zload from disk 1, lesson 0, and that just went ahead and loaded the short program. We'll hit G for go, and it takes us right into this quick little demo program, Andiar Mumps for the TI-99 4A. Introduction to Mumps. So what is Mumps? Mumps is an interpreted programming language, similar to BASIC, except there's no line numbers. Mumps works from line labels in the source code for do commands to go to line labels or go to commands, just like in BASIC. This Mumps source code is loaded into memory and is executed from memory. The Mumps interpreter is written completely in TMS 9900 assembly language, so it makes it perform pretty well, especially in comparison to native BASIC on the TI-99 4A. But then again, what doesn't run well against that version of Mumps? Mumps is a database also, so there is variables in Mumps, regular variables and arrays. And in multiple versions of Mumps, there are arrays on disk. I've not implemented that yet, but those are called globals, and those values of those variables persist on disk. Mumps is also an operating system. In the same way that BASIC is an operating system, you can load and store your programs. You can also open files for reading and writing on disk and have access to your system in that way. All right, what are the system requirements to run Mumps? Of course, you need your TI-99 4A or Classic 99 emulator. The bin files work well, and actually that's what I'm using here to create this video. To run on actual real hardware, the bin files can be put on an SD card and run from a cartridge like the Flash ROM 99 or a Final GROM. So they can certainly be created on modern equipment, written to the SD card, and then run on the original hardware. Mumps does require 32K of expanded RAM. The RAM is used to house the Mumps source code. There's 10K of space for source code and 16K of space for the variables, and the rest is used by the interpreter for other purposes. And then if you want to save your source code files, load your source code files, or open and write and read from text files, you would need a disk drive in order to do that. So to date, the progress made during the Retro Challenge is that it's a 16K ROM image, and it's what I would call working demo capabilities. And what you're seeing here is all running from a Mumps program. About the Mumps language, it has character set from 30 to 126 printable, but you can access 0 to 255 for other. Those are accessible even though they're not printable, and you may have uses for those. There's only one data type in Mumps. It is a string, but Mumps also knows when to treat strings as a number. So we'll take a string, convert it to a number, say do math, addition, subtraction, multiplication, division, put it back into a string and provide it back. So all data types in Mumps are strings, but uh, conversion when appropriate to numbers to do operations is automatically done. All commands in Mumps are single character commands. So the print command or the write command is a W. Set the value of a variable is an S. The if command is an I. The else command is an E. So it's all shorthand. The original versions of Mumps allowed for the writing out of the full word write or set, but really, if you look back historically at anyone who's written Mumps, doesn't use the full words. It just use the abbreviations, and with the limited memory and space that we have on a TI-99 4A, I only implemented the single character commands to do so. Variables, as I mentioned earlier, they're simple variables. So set A equal to 1 or set MSG equal to hello world, right? So vector variables. Also, arrays have been implemented in this working demo. So you might have a variable var, and within the parentheses you would put a subscripted variable. At this point, I've only implemented single dimensional arrays. Certainly a enhancement going forward would be multi-dimensional arrays. And all variables internally within Mumps are stored in binary trees. So where BASIC typically just keeps a running list of variables, and BASIC has to scan through the list every time to find a variable, Mumps is set up such that the variables are in binary trees, which makes lookup of variable names operate very quickly. There are operators in Mumps, so addition, subtraction, multiplication, division, all of your math operators. There's also string operators like concatenation, asking if one string lexically follows another string, and so on. So, any programming language needs its operators. Then there's intrinsic functions in Mumps, things that return the length of a string or substrings based on a delimiter, or substring based on string position, return the ASCII value of of a character, or given a ASCII value, tell me what the character is. And we'll see some of that here in a little bit. All right, so what does Mumps code look like? Mumps I've got a short program here for a fancy hello world program. Let's take a quick look. So here we can see that program starts with a line label, HW. The semicolon is for comments. So we've got here HW, line label, hello world program. Any Mumps command then starts with the space. That's how the interpreter knows that this is not a line label, but it is Mumps code. I've laid out all of these so that there's only one Mumps command per line, but certainly you can put more than one command on a line. So I have here set I equal to 0, set message equal to the string hello world. I've got another line label for hello world loop. We're going to go ahead and write the $E of message from 1 to the length of the message minus I. We're going to set I equal to I plus 1. Then we have if I is less than 11, go to hello world loop. So we'll continue to loop, and we will print the message, and we will print the message one character shorter each time. After we've done that, we're going to print done to indicate that the loop has completed, and we've got a quit command here that ends our program. So let's see how it looks when it runs. There you go, hello world, fancy style, with one less character on each one as we go. All right, so my little demo program here has concluded. I'm back at a Mumps prompt. Um, we'll look at a couple other things real quick. If we want to see the source code that's in memory, we can type in ZD, which stands for Z display. Historically, Mumps uh, system commands start with a Z. They're called Z commands, and ZD is Z display, which will display our source code. So I can just go ahead and scroll through, looking at our source code. And if I want to go to a certain line, hello world, I can go right to the source code that we were looking at. If I want to add some additional source code here, I can use the Z insert command. I'm going to just add a quick little line label here for hi, write hi, quit. We can ZD our hi, we can see it's there, and I can say do hi, and it'll execute our code. I can do zsave to save and zl to load our programs as well. So that concludes this quick introduction to Mumps. If you're interested in a little more detailed view of the Mumps programming language, I'll be posting another video to do that. So thanks for watching, and talk to you soon.